In this lesson, we are going to use PhET Beer Slow Lab to demonstrate how colorimeter or spectrophotometer works. Okay, spectrophotometers are instruments that measure the amount of light absorbed by molecules in a solution for a given wavelength. And according to the Beer-Boger law, at Beer-Lambert law, the quantity of light absorbed by a substance dissolved in a non-absorbing solvent is directly proportional to the concentration of the substance and the path length of the light through the solution. Okay, now from our general knowledge of science, we've got a solution, a colored drink, a drink mixture. So as the concentration of the drink increases, the color intensity also increases. This also works well even for other substances, chemicals such as potassium permanganate. As the concentration of potassium permanganate increases, then the concentration of the solution increases. So sometimes it's easier to label a drink dilute, a colored drink dilute or more concentrated just by looking at its color intensity. Now we are going to use the same principle in spectrophotometer or colorimetry. Okay, so for example, let's say we've got our substance, our drink mixture, which is being produced. So we are starting with a concentration of 0 at a wavelength, a specific wavelength. Then since the concentration of the drink is 0, then the transmittance is 100% and its absorbance is also 0%. So as the reaction progresses, let's say it is producing the colored substance. So as the concentration increases with the time, the absorbance increases, the transmittance decreased from 100%. So this is how it works. Then we can use the same principle to study the reaction of copper 2 sulfate with zinc granules. So as the reaction progresses, we're starting with 0.2 molar copper sulfate. So as the reaction progresses, there is decrease in the concentration of copper 2 plus ions as we are forming colorless zinc 2 plus and solid copper precipitates. So as the reaction progresses, the concentration of the copper sulfate decreases and the transmittance is increasing. So after calibrating the spectrophotometer or colorimeter, by knowing the absorbance and transmittance, it becomes easier for us to know its concentration if the wavelength is fixed and known. The absorbance and transmittance depends on the length of the cuvette. Remember, this reaction is non-disruptive, so colorimetry can operate without disrupting the course of the reaction. So let's say in this case the absorbance is 0.19. So as the length of the cuvette increases, the absorbance also increases. We can also use this reaction to study the course of reaction for the decomposition of hydrogen iodide, which is colorless. When The hydrogen iodide decomposes. It gives us colorless hydrogen gas as well as brown or purple iodine. So iodine is mostly purple in inert solvent or in gaseous state. So the color of iodine is similar to that of potassium. So we are starting with colorless hydrogen iodide. As the reaction progresses, there is increase in the concentration of purple iodine vapor. So the color intensity increases. Then we can also start the reaction between hydrogen and iodine. So we are starting with a colored mixture, but as the reaction progresses, the color intensity decreases. So as the color intensity decreases, the absorbance decrease, while the transmittance, the amount of light being transmitted, increases. So I thank you.